Hey guys, this is Gradius, and this is a video for multiplying and dividing radicals. So what we're going to do is we're going to keep working on simplifying radicals a little bit more. If you have not watched the video for simplifying radicals that came before this, please go back and watch that first, and then you can go ahead and watch this video. So what we're going to do is we're going to just multiply two numbers with radical symbols, and we're going to figure out how we can simplify those. So first what I want us to look at is what if I have something like this? So, I don't want to do that. What am I doing here? There we go. Okay, so what if I have the square root of 2, or let's do the square root of 4 times the square root of 4. So if I were to multiply these two numbers, I know that the square root of 4 is 2. I know that the square root of 4 is 2. So I have 2 times 2, which is simply 4. Okay, now there's another way I can actually do this as well if I wanted to. And this is what we're going to do if they didn't actually work out into a perfect square. What I could have also done is I could have separated the square root of 4 times the square root of 4. I could have put that all underneath one radical as a square root of 4 times 4. So if I do 4 times 4 underneath this radical, I have the square root of 16. Well, the square root of 16 is also 4. So it worked out both ways. So what we're going to do is we're going to go through this process right here for numbers that don't have perfect squares, like 6. So if I have the square root of 6 times the square root of 6, what I can actually do is I can take each number under the radical whenever I'm multiplying two radicals. I can take the numbers under the radical and then put them under one radical so they just share it. So it's just 6 times 6. And the reason why I'm doing this again is because 6 is not a perfect square, and because it's not a perfect square, I cannot simplify this any further. But what I can do is I can do 6 times 6, which is just the square root of 36, and this actually works out pretty nicely because the square root of 36 is 6, so I'm all done. Let's look at problems that are a little bit more complicated. So I have the square root of 3x times 4 times the square root of x. So what I want to do is I need to multiply everything. I need to combine everything that's underneath my radicals when I'm multiplying. So I'm going to combine the pieces under the radical and keep the pieces outside the radicals on the outside. So I have 3x and x underneath. So that's going to be the same thing as square root of 3x times x, which is another x. And I still have this 4 on the outside right here. So all of this is multiplied by 4. So I have 4 times 3x x. Well, 3 times x, now I want to see if I can simplify anything here. And if we remember from the simplifying radicals video from before, if I had 2 x's underneath the radical, that's the same thing as x squared. And if I have x squared, if I wanted to simplify this, I could do 4 times the square root of 3. And I could also expand this out to x squared. And if I wanted to find the square root of x squared, that's just going to be x. So I can take out an x out of here, so that'd be 4x times the square root of 3, and I'm all done. Okay, so the first step, take everything that's underneath your radicals and put them underneath and combine them underneath one radical sign. Everything on the outside, keep it on the outside, and then we can just go ahead and simplify everything underneath our radical symbol. Let's do another one. Again, a little bit more complicated. So first, let's do the first step of combining everything underneath our radicals together. So I will have the square root of 7xy squared. I'm just going to throw in this other x on the end. And I still have this 3 on the outside. So this is 3 times the square root of 7xy squared times x again. Well, let's combine our like terms. I've got these two x's right here. So really I have 3 times the square root of 7x squared if I combine these two x's, because there's 2 of them being multiplied. I still have my y squared. Now I want to see, can I simplify this 7 at all? Well, 7, does this have any perfect? 7's a prime number, so I cannot simplify the square root of 7 anymore. So I can't do that. But x squared and y squared, I can simplify those, because this is the same thing as 3 times the square root of 7 times the square root of x squared times the square root of y squared. So what I can do is I can pull out an x and I can pull out a y, because the square root of x squared is just x. The square root of y squared is y, which becomes 3xy times the square root of 7. And this is all the way simplified. So when dividing radicals, it's a very similar process, okay? Except what we're going to do is we're going to separate the fraction into a quotient of radicals. Okay, so what I have here is I have a radical and I have a fraction inside. What we can do is we can make this into the division of radicals. So I have the square root of 13 over the square root of 100. So what I'm doing, because this is really just 13 divided by 100. Every fraction is just another way to write a division problem. And so what I'm doing is this is really the square root of 13 and the square root of 100. So I'm separating that into what it looks like two separate problems. The square root of 13 over the square root of 100. And now I want to see, can I simplify any of this? 13 is a prime number. I cannot simplify this. Square root of 13, that's as simple as it gets. Square root of 100, however, is 10. So it becomes the square root of 13 over 10. And I am all done. Okay? Let's look at another one. Square root of 7 over x squared. So the first thing I'm going to do is I'm going to separate this into two separate square root problems. I'm going to have the square root of my numerator, the square root of my denominator. So I'll have the square root of 7 over the square root of x squared. 7 is a prime number, so I cannot simplify that. So I still have the square root of 7 on top. X squared on the bottom, however, I can simplify that because the square root of x squared is x. And this is all the way simplified. I cannot do anything else to this, and I'm done. Let's look at one more, and then we will be completely finished with this video. So I have the square root of 100 over 4x squared. So the first thing I'm going to do again is separate this into two separate square root problems. I'm going to have the square root of 100 all over the square root of 4x squared. And now what I want to do is I want to simplify both my numerator and my denominator. Well, the square root of 100 is 10. So that was easy. And then now I've got the square root of 4x squared. I can separate that just to the square root of 4 times the square root of x squared. Square root of 4 is 2. That was easy. Square root of x squared is x. So that's simplified to 10 over 2x. Now I want to see, can I simplify this any further? And if we look, we have a fraction of 10 over 2. So I can actually simplify this 10 over 2 as if it was just a fraction on all by itself over here. And 10 over 2 is just equal to 5. And it would be like 5 over 1 too if we wanted to keep it as a fraction. So I'm going to have 5 in my numerator. My denominator would have a 1 down here with the x. And there's really no point in writing that 1, so I actually don't even need it. So let's go ahead and erase that. And so my answer to this problem is just 5 over x. And there's no more radicals. We were able to get rid of all the radicals by simplifying. Okay, hope this video helped. Please let me know if you have any questions, and good luck to you.